Good morning to everyone. Myself, Vasiga, working as an assistant professor in Department of Mechanical Engineering at Adyaman College of Engineering, Hosur. Today, I am going to handle the subject that is Mechatronics and IoT. Here, we are going to see the unit number 2, System Models and Controllers. Basic System Models. This chapter relating to system models is mainly concerned to determine how systems behave with time when subject to some disturbance. For understanding the behavior of the system, mathematical models are needed. The mathematical models are equations which describe the relation between the input and output of a system. The basis for any mathematical model is provided by the fundamental physical laws that govern the system behavior. These models can be used to enlarge forecast to be made of system behavior under specific conditions. Systems can be made up of from a range of building blocks where the children used to play the building blocks with help of building houses, cars from a number of basic building blocks. Here follows the description of building blocks for mechanical, electrical, fluid and thermal systems. Mechanical buildings blocks consist of springs, dashpot and masses. Springs. The spring represents the stiffness of a system, shows a spring subject to force F. In the case of linear spring where the extension and elongation or compression is proportional to applied force. F is equal to Kx where F is equal to applied force, K is equal to a constant and X is equal to extension or compression. As per Newton's third law, the force F is equal in size and in opposite direction to the force extended by the stretched spring. That is where we will call it as F is equal to Kx. The spring when stretched stores energy, the energy being released when the spring springs back to its original position. The energy stored when there is an extension x, where E is equal to half kx square is equal to half f square by k. Therefore, f is equal to kx. The next one we are going to see that is dashpot. The dashpot represents the force opposing motion, friction or damping effect. Friction or damping effect. Here, the faster the object is pushed, the greater becomes the opposing force. In an ideal case, the damping or resisting force F is proportional to the velocity v of piston. Thus, F is equal to Cv, where C is constant. Since velocity is the rate of change of displacement x, therefore F is equal to C into dx by dt. In a dashpot, no energy is stored. It does not return to its original position when there is no force input. The dashpot dissipates the energy rather than stores. The power dissipates P is equal to Cv square. Next we are going to see the masses. The masses represents the inertia or resistance to acceleration. The mass building block exhibits a property that bigger the mass, the greater the force required to a specific acceleration, as per Newton's law, where F is equal to ma. Here, the kinetic energy is stored in the masses when it is moving with velocity v and released when it has been stops moving. E is equal to half mv square. Thank you.